My name is Alfred GÄSSLER. I'm sorry, I have an accent. I'm European, I'm not French. And as Eric introduced, yes, I am a farmer. I've sold for 5 months all over France. I know France just a little bit. Today, with my daughter Marie-Thérèse, we work on understanding the soil. We try to understand certain things, certain big ideas. It doesn't work the way it should. The more we discover, the more questions we have. And it's not logical because we're working with living things which are very complicated. Since we still don't know much, there's work to do for us and for our children who will come after us. What's important if we ask ourselves this question about the soil? It's relatively easy to understand new ideas. Everyone says it's great, but we constantly cling to the old ways. It's hard to let go. Everyone knows, for example, that corn should be sown directly and not with reduced tillage. Because if I start working the soil again, we undo part of the work the fungi have done during the cover crop period. All of that, these are things. The most important thing for me today is working on the soil is important, but it's much more important to work on your mindset. When it comes to mindset, no one is using certain systems. Secondly, for me, we shouldn't forget the influence that the farmer has on all the living things around them, on people, on the soil, but also on other people. There's another saying that goes, everyone needs a doctor once in their life, a lawyer once in their life, but 3 times a day, they need a farmer. You can be proud. What is soil quality? Is it about clay content, about sand, about silt, or is it more about the life within it? For me, it's more about the life within it. And in life, what's very important are the balances. Balances between fertile elements, between minerals, but also balances between fungi and bacteria. And today, what do we see in our soil? We have a lot of bacteria, but we have no fungi or very few fungi today. And because of that, our soil is malfunctioning, which leads to issues like compaction, and it declines in many other ways. So we need to restore that balance. And for that, the first thing is to feed the soil and stop working it mechanically. When we talk about balance, we always have to consider biology, physics, and chemistry together. When I started doing direct seeding about 20 years ago, people said, biology will come on its own. You don't have to worry about it. You just plant crops. You keep feeding plants all the time. Biology will come back. No, that's not true. If we don't have a certain chemical context, if we don't have a certain physical context, biology will degrade very quickly. And instead of the animals or fungi we need, we'll end up with pathogens. It's very important. We say that phosphorus isn't available when we don't have a certain fungus that supports the bacteria. Phosphorus will never be delivered into the soil by biological life without it. All of this means we always have to look at the whole picture and try to understand how the soil works as a system. To show you, we talk a lot about insects, we talk a lot about diseases. These are 2 mustard plants that were sown on the same day. They grew side by side for 3 months. Until one day, the mustard here was completely devoured by insects, and it took maybe 2 days. What's the difference? The difference is in the soil. Here it's a soil with an organic matter content of about 2. Here it's a soil with an organic matter content of about 3.5. We didn't do anything, we didn't add any elements. We simply let the soil do its work to see what would happen. And it seems to me the insect that ate here wasn't too lazy to go over here to this mustard plant that was right next to it. They weren't separated by a wall or anything. They were really side by side. That's what Gilles can demonstrate, as she was explaining earlier, with the overall condition of the plant's health. When it's truly good, it is indeed good. And conversely, when it's not, it is clearly not. Stressed plants produce glutathions, and glutathions attract insects. And at that point, you can do whatever you want. If the plant is stressed, it gets eaten. It's very important to have balanced soil fertility, and the plant should be able to find everything it needs during its development process. To show you a bit, I like to use photos. This is a rapeseed crop that was direct seeded in northern France a year ago. Visually, to me, the rapeseed looks very good. You could say it's too much, it's too green, it doesn't matter. But if everyone were able to grow rapeseed like this every year at this time, I think a lot of people would be happy. On the other hand, if we analyze this rapeseed now, we can see that it's lacking magnesium and boron. And why are these two elements important? Magnesium is essential for the composition of chlorophyll. That means if the plant is lacking magnesium, its photosynthesis efficiency is limited. Boron, in this case, is essential for sugar transport. If boron is lacking, the plant has trouble sending sugars down into the soil to feed the soil biology. Yesterday or the day before, it was said that it's the leaf that feeds the soil, but if photosynthesis isn't working well, it won't feed the soil properly. This is an analysis of the alfalfa plant. This is something that really shocked me personally. Alfalfa, it seems to me, is a legume that isn't able to meet its own nitrogen needs. Because, as I understand it, legumes are often used on livestock farms to feed the animals. It's lacking nitrogen, it's lacking magnesium, it's lacking sulfur, it's lacking boron, it's lacking manganese, it's lacking copper. It's impossible for this plant to function properly. And why is it lacking nitrogen? Because magnesium isn't present, boron is limited, manganese is limited, copper is limited. All of these are more or less essential elements for the functionality of photosynthesis. You can do whatever you want. With nutrition like this, it's obvious you can never properly feed the animals. But anyway, we didn't stick with alfalfa. Here, there's a leaf analysis of a cereal crop. Way too much nitrogen at the time this sample was taken. Today, we really need to think about how to best use mineral nitrogen to properly nourish plants. When you see this, it's never a good sign, because an excess of nitrogen will make the crop more susceptible to fusarium and can cause things like lodging and rust. And again, a lack of magnesium will limit the function of chlorophyll. And if there's a limitation in chlorophyll or in chlorophyll efficiency, we end up overfeeding again with nitrogen. The plant isn't able to convert the absorbed nitrogen into protein, so it ends up with too much nitrogen in its tissues. And once again, this attracts diseases and insects. And when we look at this, it's for corn. If we look at some of the diseases that exist today, what are they linked to? A lack of fungi that release calcium and phosphorus. There is always an explanation for why plants are sick today, except we don't find them in the soil, because the symptoms, as they're shown here, are actually very, very rare to see. I don't know if you're familiar with the company Precifield. It's a company that does mapping of plots nowadays, measuring 3 or 4 different values, including organic matter. And what are they finding today? In large-scale farming, the organic matter content is between 1 and 2%. And with that, it's impossible to properly nourish the plants. Why is this important? And where is the difference for me between organic matter and humus? It's something that's constantly dynamic. It's alive. And when we talk only about organic matter, for me, we have to include the living part, that means bacteria, fungi, and all the other insects or living beings in the soil. They have to be included, otherwise it can't function properly. And above all, what must we not forget? mycorrhizae without living roots. It's really the green plant that feeds the soil. It's not the residues. And when we look at what we can find in humus, the more we increase the humus content at a certain depth, automatically we increase the fertile elements. And today we focus a lot on NPK, but in humus there are all the trace elements that we don't talk about because we don't know them. That too is very important. And in humus, the elements are much more balanced than what we can provide today. When we talk about soil, you certainly know this image. What's in this soil? These are really huge things. I'm sorry, that doesn't mean anything. I know those are high numbers, but what does it mean behind them? Since I don't understand, I'll put up a chart. That means with 1% organic matter or 5, we have about, and please don't take these numbers as something absolute. We have about 2.7 tons of living beings in the soil. And if we say that a well-functioning soil should have between 4 and 6% organic matter, we need to be able to feed between 7 and 10 tons of living beings. Who is really thinking about this properly today in this system? How do you feed 8 tons of living beings with a living plant? Very few people. We spend a lot of time worrying about above ground biomass production. We talk a lot about cover crops, but what means are we actually using to produce nutrition here? If we do a theoretical calculation, I'm emphasizing this is just theory. If I have 6% organic matter, and if I calculate that in cow equivalents, which are among the 10 tons of living beings, in theory, we should be producing 180 tons of dry matter per hectare per year. If we want to achieve those numbers, we really need to rethink how we approach soil nutrition. And what is very important today is the efficiency of photosynthesis, because that's what will feed the soil. There are some people who say, today I'm not a specialist, I'm a farmer, that the efficiency of photosynthesis today of these photovoltaic panels is between 30 and 40% at most. That means we have an inefficiency in photosynthesis of between 50 and 60%. I don't know if there are people here who have photovoltaic panels on their roofs. It seems to me that when you have an efficiency of 50%, you're really not satisfied. And the difference between people and soils is that with soils, you don't hear them when they start to complain. Let's take a very simple diagram. The plant absorbs solar energy. It feeds itself with different elements. It will bring sugars, various sugars, into the soil to feed the bacteria. And depending on the nutrition here, the bacteria will release or seek out from the bedrock elements like magnesium, nitrogen, copper, everything the plant needs to feed the plant again. Now, if photosynthesis here is working very, very well, the different sugar sand, moreover, when we have diverse plants in the rotation or in the cover, the nutrition from the sugars released by the plant is completely different. And the plant is able to create lipids. What do I have here? And when the plant is able to create lipids, it will feed fungi. And these fungi, in turn, can help to humify your soil. If the plant is not well nourished because photosynthesis here isn't working properly, the nutrition is not the same. The plant is always tired from feeding itself, and when it gets tired, it doesn't have the time or energy to create lipids. And when it can't send excess nutrients into the soil to feed the fungi, we never get any humification. And what happens then? We end up with soil that doesn't function properly or malfunctions, and the plant is much more susceptible to disease due to malnutrition. We can also demonstrate this in another way. Optimized photosynthesis, digestion by bacteria, bacteria that mineralize, that seek out elements from the parent rock or elements that are locked up and release them. This results in a greater release of important elements, digestion by fungi, and humification. And why is it important to have a wide variety of species? This is a study, you can read it again here. The more species we have, the greater the root biomass. The above-ground biomass, the root biomass, and the exudates are all different. The quality of the exudates is different. Quality is not just a matter of quantity. Bacterial biomass and fungal biomass are completely different. And if tomorrow I really want to have a soil that works, I have to take this into account. It's the healthy living plant that properly nourishes my soil. The more efficient our photosynthesis is, the more lipid production we have, and the better humus formation will work. After all, humus is the foundation of how our soil functions. Here, you can see that soil creation is carried out by microorganisms. You see, the red ones are microorganisms, and the blue is water. The bacteria are represented in yellow, and the black ones are fungi. The more bacteria you have, the bacteria are the ones that start forming the microaggregates, the smallest structures in the soil, and in the end, these are bound together by fungi to properly create soil. That's what we can see here. Soil formation is beginning here. This is a soil that is a bit depleted because it lacks proper nutrition for the bacteria and fungi. And unfortunately, that's what we find a lot, especially in soils with less than 2% organic matter. Thank you very much.